Okay, so now we got another practical application question here in terms of fencing around a rectangular area. Now this is kind of interesting because you have to think here. Wait a second. It says a rancher has 100 meters of fencing that goes around this nice little rectangle. Okay. He wants to achieve this, the maximum area possible. Okay, well, wait a second. How do we do that? Well, think about this. This is length, right? That's width. So if you think about it, 2 lengths plus 2 widths, that's your distance around. That's got to equal to 100. But look, your length times width has to be a max. Well, surprisingly enough, that's a system of equations. That's right out of grade 10. So watch this. How do I solve something like this? First thing that I would do is I would say, okay, what do you want to solve for? Do you want to solve for length or do you want to solve for width? I'm going to solve for width in this case. So in other words, I want it to be W equals to something. All right. So here we go. 2 lengths plus 2 widths equals to 100. Now, solving for W means you have to subtract 2L from both sides. All right. Okay, there we go. I got rid of my L's, right? I got 2W now equals to 100 minus 2L, and now I can divide the whole thing by 2. So I've got W equals to 50 minus L, because remember, the 2 goes into the 100 and the minus 2. So that's my formula here. What can I do with this now? Well, that's W equals to. I'm going to go into my system of equations here, and I'm just going to plug it in. Watch this. This now becomes L times 50 minus L. That's got to equal to our max value. And guess what happens? Look at that. Distribute. You got 50L minus L squared. There's your max. And how do you know it's a max? It's opening down. And because it's a squared, it's a parabola. So let's put that into my calculator and actually figure out the max. So first things first, with the calculator, you got to bring it up. Here we go. I'm going to go here, and I'm also going to zoom standard this just to get everything going here, just to make sure it's 10, 10, 10 all the way across. Get my calculator going by plunking in my value. Now, I don't know what my equation was again, so I'm going to bring it up. Oh, there it is. It's going to be 50L minus L squared. So in other words, 50x minus x squared. And I'm going to graph this. When I graph this again, it might be out of the range, and it certainly is. Oh my goodness, that doesn't look like a parabola at all. So I'm going to increase my y value, and I'm going to increase my x value, and let's see what we get. And I'm just going to guess. I'm going to increase my x value to, let's say, well, let's go to 50. And I'm going to increase my y value to, let's say, oh, I don't know. Remember, we're dealing with an area of something that's got a 100-meter perimeter. Well, let's start at 100. I don't know. Let's guess. So it becomes a bit of a guessing game. Oh my goodness. Okay, well, we got an idea of what my parabola is going to look like, but obviously 100 is not tall enough. So let's go back to our windows. Let's go to our y max. Let's figure out some stuff. Let's try 300. Let's see what happens. Okay. Graph it. Let's see what we got. Oh, we're getting closer. It's beginning to look more and more like a parabola. Let's even do some more. Let's get away from the 300 because I think that's not going to be enough. Let's double that. Let's make it even more. Let's make it 800. Let's see what happens. Let's see, because I want to see that vertex. That's what we're after. There it is. Perfect. Let's find the vertex, which of course is going to be our maximum area. Second calc. Here we go. Let's find our maximum, number 4. There it is. Oh, hey, that's nice. It's pretty close to the maximum already. I'm going to mouse this over to this side. There it is. Enter, guess, enter. And I've got a maximum of x value of 25 at 625. What does that mean? That means at a value of 25, I've got a maximum of 625. So the maximum, that's our area. That's our area. At a maximum of 625. And since we're dealing with meters, that's 625 meters squared. But what does this mean? Do you remember? We were talking about, we said length. We said x, we're going to get rid of the L and substitute it with x. So that x value has to be the length. So at the length of 25 meters, you're going to have an area of 625. That's how it's going to work. Go back to here. So at a length now, right, because there's our formula that we did, okay, a length of 25, bring up the calculator just to make sure, a length of 25, okay, right? At a length of 25, we're going to have an area, which we figured out our area to be 625. Isn't that awesome? Look at that. So write a quadratic function we just did, which was, oops, right here, okay? What do the coordinates of the vertex mean? Coordinates of the vertex is 25, comma 625. That was our length. And my question is now, what is the width? Oh, well, we got a formula to figure out the width right here. This is 50. The width is 50 minus the L value, the length. 50 minus 25 works out to be a width of also 25 meters. Wow, so our length and width are exactly 25 meters. The maximum area is 625. And that's how you figure it out on your calculator.